128 mm gun, 150 mm of frontal armor, 69 tons of German engineering at its absolute peak, 122 mm gun, 120 mm of sloped frontal armor, 46 tons of Soviet heavy metal. Berlin, April 1945. The streets of Germany's capital became the battlefield for the two most powerful tanks ever to face each other in World War II. The German Tiger II King Tiger, designed to be invulnerable and unstoppable. The Soviet IS-2 Josef Stalin tank, built to smash through any defense. Both arrived too late to change the outcome of the war. Both represented their nation's tank design philosophy taken to the extreme. Both were mechanical marvels that were simultaneously too heavy, too expensive, and too complex for the war that was actually being fought. This is the story of two tanks that should have dominated the battlefield, but didn't. Why the heaviest armor and most powerful guns in World War II failed to achieve strategic impact. And what happened when these titans finally met in the ruins of Berlin? The Panzerkampfwagen 6 AUSFB Tiger II, commonly called the King Tiger or Royal Tiger, represented the ultimate expression of German heavy tank philosophy. Build an invulnerable fortress on tracks with a gun powerful enough to destroy any enemy armor from ranges where return fire was impossible. Development began in early 1943, as German military leadership recognized that the Tiger I, impressive as it was, would eventually be countered by improved Allied weapons. The Tiger II was designed to maintain German armor superiority for years into the future. By incorporating every lesson learned from Tiger, one combat experience, while adding heavier armor, a more powerful gun, and improved mechanical systems. The result was the most heavily armored and armed production tank of World War II, a vehicle so imposing that Allied tank crews who encountered it reported feeling helpless. The problem was that by the time the Tiger II entered service in mid-1944, Germany was losing the war on all fronts and could not produce, fuel, or support these massive tanks in numbers sufficient to affect the strategic situation. The Tiger II's specifications were staggering and represented engineering achievement pushed to impractical extremes. The tank weighed 69.8 tons fully loaded, making it the heaviest production tank to see combat in World War II. The frontal armor was 150 millimeters thick on the turret front and 100 to 150 millimeters on the hull front. Both sloped at angles that increased effective thickness dramatically. This armor scheme made the Tiger II effectively immune to nearly all Allied anti-tank weapons from the front. American 76mm guns, Soviet 85mm guns, British 17-pounders, none could penetrate Tiger II frontal armor at normal combat ranges. Only specialized weapons, like the Soviet 122mm gun on the IS-2 or American 90mm gun, could potentially penetrate from the front, and even then only at close range with perfect shot placement. The main armament was the 71 caliber 88mm KWK-43L71 gun, one of the most powerful tank guns ever mounted in a turret, capable of penetrating 200 millimeters of armor at 1,000 meters. This meant the Tiger II could destroy any Allied tank from ranges exceeding 2,000 meters, while remaining invulnerable to return fire. In pure combat capability, the Tiger II was unmatched. The Tiger II's mechanical problems were as impressive as its combat capabilities. The Maybach HL230P30 engine produced 700 horsepower, adequate for moving the Panther at 45 tons, but completely inadequate for pushing 70 tons of Tiger II. The power-to-weight ratio was barely 10 horsepower per ton, giving the Tiger II sluggish acceleration and poor cross-country performance. Maximum speed was listed as 41 kilometers per hour on roads, but rarely achieved in practice. Off-road speed was often less than 10 kilometers per hour on soft ground. The transmission and final drives were stressed beyond their design limits and failed with frightening regularity. Tiger. 2 units moving to new positions typically lost 20 to 30% of their vehicles to mechanical breakdown before reaching the front lines. Once in position, Tiger IIs that didn't move lasted longer, but any tactical maneuver risked catastrophic mechanical failure. The overlapping road wheel system, while providing excellent weight distribution, was prone to jamming with mud and debris. In winter, mud would freeze between the wheels overnight, immobilizing the tank completely until crews could chip away the ice, a process that could take hours. Fuel consumption was catastrophic and became Germany's most critical limitation in employing Tiger IIs effectively. The tank consumed approximately 450 liters of gasoline per 100 kilometers on roads and far more off-road or in combat. With a fuel capacity of 860 liters, the Tiger II had an operational range of barely 150 kilometers under ideal conditions and often less than 100 kilometers in combat operations. By 1944, Germany was experiencing severe fuel shortages as Allied bombing destroyed refineries and Soviet advances captured Romanian oil fields. Tiger II units were frequently immobilized not by enemy action, but by empty fuel tanks. Many Tiger IIs were abandoned in perfect working order simply because there was no fuel to move them. German tankers learned the bitter lesson that the most powerful tank in the world was useless when it couldn't reach the battlefield or move once it got there. Production numbers tell the story of Germany's strategic impossibility. German industry built exactly 489 Tiger IIs between January 1944 and March 1945, an impressive achievement given Allied bombing campaigns, but completely inadequate for Germany's strategic needs. These 489 tanks were distributed across the Eastern Front, Western Front, and occasionally Italy, meaning individual German units received perhaps a dozen Tiger IIs mixed with Panther and Panzer IV tanks. There were never enough Tiger IIs to form pure King Tiger battalions, except for a few elite SS units. Most German armored divisions never saw a Tiger II at all. The production rate averaged about 40 to 45 tanks per month at peak, constrained by the complexity of manufacturing 70-ton vehicles and the increasing disruption of Allied bombing. For comparison, Soviet factories were producing over 300 IS-2 heavy tanks per month during the same period. The numerical disadvantage was insurmountable. German crews who received Tiger IIs had mixed feelings about their new mounts. On one hand, the Tiger II provided a level of protection and firepower that made crews feel nearly invincible in combat. Veteran tankers who had survived Tigers, Panthers, and Panzer IVs reported that the Tiger II made them feel safe for the first time, at least when facing enemy tanks. The thick armor meant crew survivability was much higher than in earlier tanks. When Tiger IIs were penetrated, which was rare, the large internal volume gave crews better chances of surviving the hit. On the other hand, the mechanical unreliability and fuel consumption meant Tiger II crews spent more time as mechanics than tankers. Crews learned to perform extensive maintenance after every movement, checking the transmission, final drives, suspension, and engine for stress damage. Despite these efforts, breakdowns were routine. Tiger II crews joked darkly that their greatest enemy was not Soviet or American tanks, but German engineering that demanded perfection in conditions where adequate reliability would have been more valuable. The IS-2 Josef Stalin heavy tank represented the Soviet Union's answer to German heavy armor and reflected Soviet design philosophy. Build a heavy tank that could destroy any enemy armor while maintaining the mobility, reliability, and production capacity that sustained Soviet armored operations. Development began in late 1943, after Soviet forces encountered Tiger tanks and recognized that existing Soviet heavy tanks the KV-1 and KV-85, were inadequate against German armor improvements. The IS-2 was designed from the ground up to defeat Tigers and Panthers, while avoiding the mechanical complexity and production bottlenecks that plagued German heavy tank programs. The result was a tank that balanced heavy firepower and armor protection with acceptable reliability and production capacity, embodying the Soviet approach to weapons design: adequate performance in overwhelming numbers rather than maximum performance in limited quantities. The IS-2's most distinctive feature was its massive 122mm D-25T gun, the largest caliber gun mounted on any production tank during World War II. This weapon fired a 25-kilogram armor-piercing projectile at 780 meters per second, capable of penetrating 160 millimeters of vertical armor at 1,000 meters. Against the Tiger II's sloped frontal armor, the 122mm gun could achieve penetration only at ranges below 500 to 600 meters, with careful shot placement. But against side armor or other tanks, the 122mm was devastating. The high explosive shell was equally impressive, weighing 25 kilograms and containing enough explosive to demolish buildings, destroy fortifications, and create shock effects that could disable tanks even without penetration. Soviet tank commanders learned that firing high explosive rounds at Tiger IIs while not penetrating the armor could damage external components, injure crews through spalling, and force Tigers to retreat. The IS-2's gun made it valuable not just as a tank destroyer, but as an assault gun capable of supporting infantry attacks against fortified positions. The IS-2's armor protection was substantial, but carefully optimized for both protection and mobility, rather than maximum thickness. The frontal hull armor was 120 millimeters thick set at 60 degrees, providing effective protection equivalent to approximately 240 millimeters of vertical armor through slope multiplication. The turret front was 100 millimeters thick, with complex curves that increased effective thickness. This armor scheme made the IS-2 immune to most German tank guns from the front at medium and long ranges. Panzer IV guns could not penetrate IS-2 frontal armor at any range. Panther guns could penetrate only at close range with careful aim. Only the Tiger II's 88mm gun and specialized anti-tank weapons could reliably penetrate IS-2 frontal armor. The side armor was 90 millimeters, thicker than most tanks' frontal armor, giving the IS-2 good protection even when flanked. The weight of 46 tons represented a careful balance: heavy enough for effective protection, light enough for acceptable mobility and mechanical reliability. Soviet engineers understood that a tank that broke down frequently or consumed too much fuel was strategically useless, regardless of its combat capabilities. Soviet production capacity for the IS-2 demonstrated the fundamental difference between Soviet and German industrial approaches to heavy tank manufacturing. Soviet factories produced approximately 3,854 IS-2 tanks between late 1943 and the end of the war, nearly 8 times German Tiger II production. This production achievement was possible because the IS-2 was designed specifically for mass production using Soviet manufacturing capabilities and available materials. The armor was primarily rolled plate rather than complex castings, simplifying production. The mechanical components were adapted from existing Soviet heavy tank designs, reducing development time and allowing factories to use existing tooling. The gun, while powerful, was a modified version of an existing field artillery piece, rather than a completely new design. Every aspect of the IS-2 was engineered to be producible by Soviet factories staffed largely by women and teenagers with minimal industrial experience. The result was a heavy tank that could be built in numbers sufficient to equip entire heavy tank regiments, while German heavy tanks equipped only a few elite battalions. The IS-2's operational characteristics reflected Soviet battlefield requirements and tactical doctrine. The tank could travel approximately 240 kilometers on roads with full internal fuel, significantly better than the Tiger II's range despite similar fuel capacity. The Christie suspension provided good cross-country mobility and a relatively smooth ride for the crew. Maximum speed of 37 kilometers per hour was adequate for keeping pace with medium tank formations. The crew of 4, commander, gunner, loader, and driver, had cramped but functional positions. The main limitation was the gun's slow rate of fire, approximately 2 to 3 rounds per minute due to the separate loading ammunition that required the loader to handle the massive 25-kilogram projectile and separate propellant charge for each shot. This slow rate of fire meant IS-2 crews had to make every shot count, but Soviet doctrine emphasized careful shooting over volume of fire anyway. Soviet tank crews were taught to wait for clear shots rather than shooting wildly, a doctrine that suited the IS-2's capabilities perfectly. Soviet tactical employment of the IS-2 reflected its strengths and limitations, while adapting to the reality of German heavy armor. IS-2s were typically organized into separate heavy tank regiments of 21 tanks attached to combined arms armies rather than distributed among regular tank units. These heavy tank regiments were used as breakthrough forces to smash through German defensive lines, assault fortified positions, and provide heavy firepower support for infantry advances. When IS-2s encountered German heavy tanks, Soviet doctrine called for using superior numbers and combined arms tactics rather than seeking individual duels. Artillery would suppress German positions, infantry would advance to spot enemy tanks and prevent German infantry from flanking IS-2s, and multiple IS-2s would coordinate to create flanking opportunities rather than engaging Tigers frontally. Soviet commanders understood that even with the powerful 122mm gun, frontal engagements with Tiger IIs were risky and to be avoided when possible. Better to use the IS-2's mobility and numbers to create advantageous engagements than to fight on German terms. Direct engagements between Tiger IIs and IS-2s were surprisingly rare, given that both tanks were deployed on the Eastern Front during the final year of the war. The Tiger II entered service in summer 1944, just as Soviet forces were launching their massive Bagration offensive that destroyed German Army Group Center. Tiger IIs were deployed in small numbers to critical sectors attempting to stop Soviet advances, but they were consistently outnumbered and often bypassed by Soviet breakthrough operations. The IS-2 had been in service since early 1944 and was present in increasing numbers as Soviet production ramped up. However, the strategic situation, massive Soviet offensives overwhelming German defensive positions, meant that prolonged tank battles, where Tiger IIs and IS-2s could engage under controlled conditions, were uncommon. Most encounters occurred during meeting engagements, in German counterattacks, or during the final battles for Berlin and other German cities where close-range urban combat favored neither tank's design strengths. The technical comparison reveals why direct duels were so deadly for both sides and why both tanks' crews tried to avoid fair fights whenever possible. In a hypothetical engagement at 1,000 meters on flat terrain, with both tanks aware of each other's position, the Tiger II held decisive advantages. The 88mm KWK-43 gun could penetrate IS-2 frontal armor at this range with proper shot placement, while the IS-2's 122mm gun could not reliably penetrate Tiger II frontal armor at 1,000 meters. The Tiger II's superior optics gave German crews better target acquisition and ranging accuracy. If both tanks shot simultaneously, the Tiger II would likely penetrate while the IS-2's shot would bounce off the sloped armor. This technical advantage made Tiger II crews confident when engaging IS-2s at long range in open terrain, where German gunnery and optical advantages were maximized. However, battlefield conditions rarely matched this theoretical ideal. Urban combat in Berlin and other German cities reduced engagement ranges to 100 to 300 meters, where the IS-2's massive 122mm gun could penetrate Tiger II armor, and where Tiger II advantages in optics and long-range accuracy meant little. Soviet tactics increasingly focused on creating these close-range encounters, where IS-2 advantages in numbers and rate of advance mattered more than Tiger II advantages in armor and gun performance. Soviet commanders learned to use infantry scouts to locate Tiger IIs, then coordinate multiple IS-2s to engage from different angles simultaneously. A Tiger II could destroy one IS-2, but faced difficulty engaging multiple targets from different directions. While the Tiger II crew was traversing to engage the second IS-2, the third could maneuver for a flank shot where even the Tiger II's side armor was vulnerable to the 122mm gun. The few well-documented encounters between Tiger IIs and IS-2s confirm both tanks' deadly effectiveness and the importance of tactics and numbers over individual tank characteristics. At Ogledow, in Poland, in August 1944, a single Tiger II from Schwer Panzerabteilung, 501 engaged Soviet armor, including IS-2s, destroying several Soviet tanks before being immobilized by mechanical failure, not enemy fire. The Tiger II crew abandoned the tank, and it was later captured intact, giving Soviet engineers their first opportunity to examine a Tiger II in detail. This encounter demonstrated both the Tiger II's combat effectiveness when functioning and its mechanical vulnerability when stressed. During the defense of Budapest in late 1944 and early 1945, German Tiger IIs engaged Soviet IS-2s in urban combat, where close ranges and limited visibility negated many Tiger II advantages. Both sides achieved kills, but Soviet numerical superiority meant that for every Tiger II destroyed, several IS-2s were available to continue the attack. These encounters validated the fundamental principle that the tank available in greater numbers with adequate performance typically defeats the technically superior tank available in limited quantities. The Battle of Berlin in April to May 1945 saw the largest concentration of both Tiger IIs and IS-2s in the same combat zone, and provided the most extensive data on their relative performance under real combat conditions. German forces defending Berlin included several Tiger IIs from various Schwer Panzer units, scraped together for the final defense. Soviet forces attacking Berlin included multiple IS-2 heavy tank regiments, spearheading the assault. The urban environment created chaotic close-range combat where neither tank could fully utilize its designed advantages. Tiger IIs positioned in defensive positions achieved impressive kill ratios, but were progressively overwhelmed by Soviet numbers and combined arms tactics. IS-2s advancing through Berlin streets took heavy losses from Tiger IIs, Panther tanks, and infantry anti-tank weapons, but Soviet forces could absorb these losses and continue attacking, while German forces had no replacements. Many Tiger IIs in Berlin were destroyed by infantry with Panzerfaust or by Soviet artillery, rather than in tank-versus-tank duels. Several Tiger IIs were abandoned by their crews when fuel ran out or mechanical failure immobilized them. The battle demonstrated that even the most powerful tanks became vulnerable when surrounded, low on ammunition and fuel, and without infantry support. Crew quality differences affected outcomes significantly, but less than in earlier periods of the war. By 1945, many German Tiger II crews were inadequately trained as experienced tankers had been killed, and fuel shortages limited training time for replacements. The complexity of the Tiger II meant that inexperienced crews could not fully utilize its capabilities. Soviet IS-2 crews by 1945 were battle-hardened veterans who understood their tanks' limitations and had developed effective tactics through hard experience. The crew quality advantage that Germany had enjoyed early in the war had largely evaporated by 1945. In engagements where both crews were experienced, the Tiger II's technical advantages mattered. In engagements where one or both crews were inexperienced, chance and circumstances often mattered more than tank characteristics. And in the broader strategic context, Crew quality for individual tanks meant little when one side could field 10 tanks for everyone the enemy deployed. The Tiger II versus IS-2 comparison ultimately demonstrates why both tanks, despite representing the peak of World War II heavy tank development, failed to achieve decisive strategic impact. Both arrived too late in the war to affect its outcome. Both were too heavy and complex for the deteriorating logistical situations their respective militaries faced. Both existed in numbers too small to achieve the breakthrough or defensive dominance their designers intended. And both represented their nation's approaches to military procurement, taken to unsustainable extremes. Germany, building a few perfect weapons while losing wars of attrition. The Soviet Union building adequate weapons in overwhelming numbers while accepting higher casualties to achieve strategic objectives. The Tiger II represented the ultimate expression of German engineering perfectionism applied to tank design and demonstrated both the strengths and fatal weaknesses of that approach. The Tiger II was the most heavily armored, most powerfully armed, most technically sophisticated tank of World War II. In individual combat encounters under favorable conditions, it was nearly unbeatable. German engineers had created exactly what they set out to create: an invulnerable fortress on tracks. The problem was that Germany needed 5,000 reliable medium tanks more than it needed 500 perfect heavy tanks. The resources invested in Tiger II development and production would have produced significantly more Panthers or Panzer IVs that could have been produced earlier, maintained more easily, and employed more flexibly. The Tiger II's perfectionism made it too expensive to build in adequate numbers, too complex to maintain in field conditions, too heavy to transport efficiently, and too fuel-hungry to operate in Germany's fuel-starved 1944-45 logistics situation. German engineering created a masterpiece that was strategically irrelevant. The IS-2 represented Soviet pragmatic brutalism applied to heavy tank design. Build something powerful enough to accomplish the mission using available resources and accept limitations that don't prevent mission accomplishment. The IS-2 was not perfect. The gun had a slow rate of fire. The armor could be penetrated by German heavy tank guns at close range. The internal volume was cramped for the crew. But the IS-2 could be produced in numbers that mattered, maintained by field mechanics with basic tools, fueled and supplied through Soviet logistics, that functioned adequately despite enormous strain, and employed in the breakthrough and assault roles that Soviet doctrine required. The IS-2 was good enough to break German defensive lines, good enough to support infantry attacks, good enough to engage German heavy tanks when necessary, and good enough to reach Berlin in May 1945. Soviet engineers understood that adequate performance in quantity matters more than perfect performance in scarcity. The IS-2 validated that understanding. The broader lesson of Tiger II versus IS-2 is that weapons must be designed for the war that is actually being fought rather than the war that procurement officers wish they were fighting. Germany in 1944-45 needed mobile, reliable tanks that could be produced in thousands, maintained easily, and fueled from limited supplies. Germany built Tiger IIs instead. The Soviet Union needed heavy tanks that could break through German defensive lines and provide heavy fire support in adequate numbers to equip entire regiments. The Soviet Union built IS-2s that accomplished exactly that mission. The comparison is not really about whether the Tiger II or IS-2 was the better tank in abstract technical terms. The Tiger II was clearly superior in armor, gunpowder, and crew protection. The comparison is about which tank better served its nation's strategic requirements in the specific circumstances of 1944-45. By that measure, the IS-2 was superior, because it existed in numbers that mattered and accomplished the missions required, while the Tiger II existed in numbers too small to affect strategic outcomes. The final verdict is that both the Tiger II and IS-2 were too late to change the war's outcome, but for different reasons. The Tiger II was too late, because by the time it appeared in mid-1944, Germany was already losing on all fronts, and no tank, however impressive, could compensate for the fundamental strategic situation of fighting the combined industrial might of the Soviet Union, United States, and British Empire simultaneously. The IS-2 was too late because the T-34 medium tank and earlier Soviet heavy tanks had already accomplished the mission of defeating German armor and breaking through defensive lines. The IS-2 was an improvement that made breakthrough operations easier and reduced Soviet tank casualties, but it was not necessary for victory in the way that improved German tanks were necessary and insufficient for German survival. The legacy of the Tiger II and IS-2 comparison is visible in post-war tank development. The Tiger II approach, maximum armor and gun power regardless of weight and complexity, was abandoned by all nations. Post-war tank development prioritized balanced designs with adequate armor, adequate guns, good mobility, mechanical reliability, and production capacity. The IS-2 approach, heavy tanks, as specialized breakthrough vehicles separate from main tank forces, influenced Soviet Cold War heavy tank development, but was eventually abandoned in favor of main battle tanks that combined adequate protection, firepower, and mobility in a single design. Neither the Tiger II nor IS-2 represented the future of tank development. Both were evolutionary dead ends that demonstrated the limits of weight and complexity. The future belonged to medium-weight main battle tanks that balanced competing requirements rather than optimizing any single characteristic. That lesson was written in the ruins of Berlin, where Tiger IIs and IS-2s fought their final battles in a war that had already been decided by production capacity, logistics, and industrial strategy, rather than by individual weapons performance. Subscribe for more daily World War II tank comparisons. Comment below if you had to command either a Tiger II or an IS-2 in Berlin 1945, which would you choose and why? The debate between engineering perfection and adequate numbers continues.